notes, okay, from part 1, part 2, and part 3. So actually part 1 in week 5 is actually I note here part 1 and part 2, means that the portion of lecture note part 1 here is included inside this week 5 lecture note. Okay, so we just refer to this week 5. Okay. Right, so don't forget to fill in the attendance, to take the attendance for week 5. Okay. So next week, there will be no lecture. So I cover week 5 and week 6. Okay, and then we see on week 7. We have face-to-face lecture week 7. Okay, on Monday. All right, for today's lecture, so just we have done the exercises yesterday. Okay, kita dah buat latihan kemarin. Okay, today I will explain a bit kind of revision lah actually. You can see here, we already discussed about continuous assignment. Okay, and the keyword is assign. Single pass behavior, the keyword is initial. So initial we use in test bench only, not in design. We don't use initial in design. And the last one, types of behavioral model, we call as cyclic behavior. So the keyword for continuous is assign. Okay. Keyword for pass initial, and the keyword for cyclic behavior is always. And then always can be always at A or B, C, and so on. So this is what we call as level sensitive. And we can also represent using cyclic behavior model, which is for what we call as synchronous logic, so sequential logic. What's H, CLK. Okay. This is what we call as H. So this is actually the summary lah. And this is for sequential logic. Logic circuit. Okay, like what we call counters, okay, memory, and so on. Any logic that use clock, we call as a sequential logic. Okay. And then the level sensitive, either high or low. Okay, either high or low. And then this is to model a combination logic. Okay, hope everyone clear on this. To model combinational logic circuit, we use level sensitive. Okay, and then to model sequential logic circuit, we use H sensitive, right? And initial normally we use for test bench. Okay. Assign statement normally we do in both and we don't have any memory element for assign statement. So there we have continuous data, means that we don't have the past or the previous data. Okay, information on the previous data is not recorded. Okay, it always continuously update the data. So that's why we call as continuous. As compared to the cyclic behavior, we have what we call temporary memory element. Okay, in between the either in between the rising edge of the clock or in between the level of the signal. Okay, for example, maybe I can sketch a bit here. For the case of sequential logic circuit that we did yesterday about the counter. So we use the clock. Okay. So this is a clock signal. And then if you run using model sim, okay, maybe you will see the what we call the counters either count up or count down. For example, it counts up. For example, so let's say it active. No, sorry, is a positive H clock. So positive H clock, which is during this one, okay, on every rising edge of the clock. So here, so means that your numbers, your counter will change its value on every rising edge of the clock. So like this one. So this is actually a bus representation. Okay. If you run quarters, model sim, you should be able to see like this. This is a bus representation of your data. So yesterday we did, I think 4-bit. Okay, and then okay. So let's say we count from 0, for example. So here is 0. Okay, for 0, 4-bit, 4-bit binary value. 0, 0, 0, and then here is 0, 0, 1, and then the next one, okay, 0, 0, 1, 0, and the last one 0, 0, 1, 1, for example, and then we have another numbers lah, okay, counting up. Okay, what I want to show you here is actually, if you can see here, the value of the number from 0, 1, 2, and 3 is changed on every rising edge of the clock. See, it's changed or updated every rising edge of the clock. This is because in your program, you write always is at H CLK, okay, and then you mention here between, and have count C out equal to C out as 1. Fine. Okay. So what happened is actually on every rising edge of the clock. So because of positive edge clock here, so this is inside the sensitivity list. So recall back. So anything change inside the sensitivity list will update the value in here or the process in here. So in this case, the process in here is actually a counting up operation, increment by 1. Okay. So let's say the C out is 0, initial value is 0. So it will count up from 1, okay, 2, 3, and so on, right? So when it happens, so it happens during the positive edge of the clock or during the rising edge of the clock. So here lah, every rising edge of the clock. Kalau you tengok kat sini. Okay, and then the other thing is you can see the C out is we declare this as a register data type. So recall back, so it register data type. Why register data type? So that's actually the rule. Any left-hand side element inside the always procedural block, so this is inside the always procedural block, has to be a register data type. So why? Okay, because the C out will memorize its previous value until the next rising edge of the clock. You see here. So that's why you see the pattern of 0 and 1 is not changed until the next rising edge of the clock. So it remains, for example, here, until the next rising edge of the clock here, and so on. So that's what we call as temporary element or temporary memory. It memorizes the previous value in between the rising edge of the clock in this case. So unlike the continuous assignment, okay, it cannot maintain the value like this one. It will update, keep updating the value continuously. Right? Any question? Ada soalan? Before we go into more detail, hopefully you clear. If you have any question, just let me know. You can stop me and then ask a question. All right. Okay. So flow concept in Verilog. So we have two flow in concept in Verilog. Okay. So like in C program, okay, the flow concept in C program only sequential. We don't have concurrent. But in Verilog, we have concurrency. Okay, we will look into detail after this. And then we also have discussed about the if-else statement. Kita dah bincang about the if-else statement and also case statement. Okay, these two is actually very important lah untuk kita buat behavioral model, especially using cyclic behavior. Sebab tu you tengok ada always lah, selalu dia menggunakan always wrong. It can either always at inside positive edge clock or always at level sensitive. Okay, so that's what we call as control flow. Dia akan control the process flow inside the block yang ada dalam dia. For example, yesterday we did about reset kan. We have reset. So if reset, Cout equals to 0, else Cout equal to 1. So that's actually the process control flow lah. Okay, they control the operation. For example, we have here yesterday. So if reset, then what happened? Reset Cout equal to 0. Okay, maybe 4 prime be 0. Or else, okay, maybe I move somewhere here so that we can see it easily. Else Cout equal to Cout plus 1. So this is what we call as control. It's control the flow. So you have to execute this first. Okay, the check dulu. Reset ni ataupun tak. Okay, if reset, do this. If not, perform the count operation, count up operation. So that's actually what we call as control flow operation. So cuba move somewhere yang kita nampak. Okay. Any question? Tak ada? Okay. So sebelum tu, maybe we have the declaration of the module count 4, for example. And then we have the I/O declaration. Input CLK, okay, and then reset, and then we have output 4-bit, so 3, 0, and we have COUT. It has to be registered at the time. Then we have AND module. That's actually a complete code lah. Okay, if you are asked in exam, please come up with the complete code, not only the portion of the code. So come up with a complete code so that I can see your declaration of I/O, the way you represent the data wave, and also the data type as well. Right? If you have any question, just let me know. Stop me and then ask. Okay. So this is actually a complete code for counter. It's basic counter. Okay. For the lab, please don't do like this. You need to modify, make it more complicated. It's up to the level at 10% for your lab. Don't do simple like this. Okay. Right. So now this is actually the detail explanation. Okay. You can read on your own, this one. So normally behavioral model it describe function. Okay. Function of a circuit, okay, for example, counter just now, without relying on any particular technology. Okay, we didn't involve any particular technology. The reason why, because we can easily migrate our FPGA or our design to a FPGA to ASIC design to any type of FPGA, for example, Ziding FPGA, Intel FPGA or other type of FPGA. So that's why it need to be independently, okay, independently of technology. It's not designed to suit certain technology. So that's actually the best design or model, okay. The best behavioral model. Okay. So another thing is describe the functional relationship between the input and output. So we have seen the example just now. Okay. All right. So as I mentioned to you, so continuous single pass and cyclic behavior, keyword and so on. So please take note. Okay. These are actually the how what element that can be used okay, to design or to model using behavioral model. So we can design combinational logic. So we did on the what we call AND gate, for example, in our lab 0, 5 input AND gate. Okay. We also did on multiplexer. Okay. So this is an example of combinational circuit, okay, using always block or using assign statement, right? Always block, cyclic behavior, assign statement, continuous assignment, okay? We can also represent for sequential logic circuit, okay? Sequential logic circuit using age sensitive, right? Age sensitive. Level sensitive, like I mentioned to you all just now, I cannot use always block just now. Using always, maybe I can write here. Using always. Always. Maybe I make it bigger. Always. So add any signal lah, A or B or C and so on. So that's what we call as level sensitive. This one, always. For speech, clock, for example, or always at each clock. And this one, normally we use assign statement. Okay. Y, A, and B, for example. Cannot see. And we can also use a behavioral model to represent finite state or data path controller. Okay, this will be covered, I think, week 7. We try to cover week 7. Right. So if I have time, maybe I will upload the recorded video during week 6 Okay, week 6 next week. Okay. All right. So I think we cover all already. Data path and also finite state machine in terms of introduction. So activity flow in Verilog, as I mentioned just now, we can implement concurrent or sequential. So every piece of code that is classed under concurrency is executed at the same time. So that's actually meaning by concurrent, serentak, ataupun kita panggil sebagai in parallel or simultaneously. So that's actually the same words. Okay. Every piece of code that is classed under sequential is executed one after another. Okay, one instruction at a time after another. Okay. So in Verilog, we can model these two, what we call these two concepts, okay, concurrent and sequential. Okay. So how we implement concurrent, for example. So this is actually the example. In our design, okay, we have multiple always block. You can see here, nampak. So these 3 always block is actually has its own processes, their own processes. So each of the process, okay, each of the processes actually executed concurrently if we implement like this way 3 always block. Okay, but be careful when you have like this one 3 always block. Be careful of race condition. There can either issue race condition. Race condition means that if you have A equal to, for example, Z. So we have output Z, Z equal to A. Okay? And at the same time, you also have here Z equal to B. This is what we call as race condition. So which one Z will be updated? So it will be a race condition lah. So Z akan confuse. Mana satu yang dia nak pilih, A ke B? So that's what we call as race condition. Okay, so we need to avoid lah, okay, that kind of race condition. And this is actually the advantage of Verilog lah. We can use multiple always block for operation that requires simultaneous access ataupun concurrent ataupun parallel computation, okay, of independent data, okay, of independent data, okay. So independent tu maksudnya data dekat sini tak bergantung kepada always block ni, samalah dengan yang bawah dan seterusnya. And that's what we call as independent. And towards the end baru kita combine, and that's okay. If data is independent, we cannot use a parallel lah. Okay. Okay, sequential. How about sequential? So I think we all familiar with this kind of code. Kita pernah tengok, right? So sequential statement is, for example, a statement start with always and inside the sensitivity list. So this is a sensitivity list. So if A, means that if A equal to 1 lah, if A equal to 1, if A equal to 1, so Y equal to 1. If A equal to 1, Y equal to 1. So else if A not equal to B, Y equal to 0. So it happened one instruction after and then followed by the next one. So it's not happen concurrently. You check one first. Ini dulu, dia update yang ni, and dia check yang ni, dia update. Okay, yeah? So that's what we call as sequential. Right? Here is actually the summary between concurrent and sequential. Okay? So which one is concurrent? The pink one or the green one? Concurrent.
Pink.
Yeah, so the pink one is the concurrent lah. Okay? And the green one is actually a sequential one after another. So we can have sequential inside concurrent. For example, we can have execution inside here sequential, but in between this operation we have parallel operation. Okay. Right? So this is what we call as activity flow control, as mentioned before. So we can use case statement, we can use conditional statement if else, conditional statement if else, and we can also use loop. If you remember, we normally use loop ni untuk test bench. For example, test bench style number 1, we discussed already. We have four open bracket, close bracket, I equal to 0. Remember, I less than 4, and then I equal to I plus 1. Remember, okay? This is actually what we call as for. Okay, we can also use repeat and also forever. Okay, so forever is actually used to represent a clock signal. Okay, for example, how do we design our clock signal in test bench like this one? So it's actually kind of repetitive. Nampak tak? The pattern itu repeat. So when you see the clock period itu adalah ini. So T dekat sini. And then dia repeat lagi. Another T. Nampak tak? So it's actually kind of repetition. For example, so we have this 5 time unit. And this is 5 time unit as well. Then the clock period is actually 10 time unit. How do we represent this in Verilog? So normally we can also use forever. Forever. Okay. Then we set our amount of time. Okay, 5. So you want to repeat. So clock CLK equal to inverted CLK. So this is actually how we represent the clock. So it will keep repeating. Every 5 time unit, it will invert. So from 1 to 0 or from 0 to 1. So finally, we get the clock signal. Right? Any question?
No.
No? Okay. All right.
No, sir.
Okay, okay. Okay. So example of forever tu maybe you can try in your what we call in your lab lah, okay, or your assignment. Okay, you can explore. Okay, conditional if else statement. Same lah. I think we have discussed this multiple times. So this is what we call as condition. Okay, condition. If A and B means that if A is actually what kind of logic it compare these two. If A and B ni maksudnya dia buat macam operation of AND gate. So A and B. Maksudnya if A both of them if one, okay, if both of these one and then true lah. If this true and then it execute this. Otherwise, it will check the next one. If A and B equal to 1, means that A, 1, C, 1, and then true lah. So if this true, and then it will do this one. If none of these true, and then it will do the next one. You can see this. So that's what actually the function of if else. So it's what we call as conditional. Kita set condition kat dia. So these two are the condition lah. Okay, don't put like macam yesterday I see student put else, you put macam ni. Ini you put A and B for example. So this tak boleh. Okay. Kalau you ada if and then okay. Baru dipanggil sebagai conditional. Kalau you tak else saja maksudnya you kena buang ni. You letak terus solution kat sini. Macam ni. Okay, else and then do this. So remember to have begin and end if you have more than one line. Jadi more than one line of statement, you need to have begin and end. So yeah. Incomplete if else statement. So we have condition di mana kita terlupa nak letak else dekat ujung dia. Contoh macam ni, kita terlupa letak else ni. So you letak macam ni. Lupa letak inilah maksudnya hilang yang ni, yang portion ni. Okay, lupa portion ni. Bila you tak letak portion ni, you tinggal if saja kat sini without else, so your design is actually not a good design. Why? Because your design will create an unwanted logic atau unwanted latches kita. Okay, because it not specify all possible combination. Dia tak specify combination yang semua yang possible. Not specifying all possible condition. Jadi tak ada if not having else. Okay. Maksudnya logik you punya set tu ataupun quarters tu akan sendiri assign dekat you punya design tu. Which akan berlaku unwanted latches lah. So a good designer akan specify ada else statement di situ. Okay. Condition 1, contohlah if without else. Dia ada else if lepas tu kita ada else. So all possible condition of the A and B are specified. Dalam kes ini A and B semua dia specified. Okay. Apa yang berlaku? Dia specified, okay lah. Tapi contoh macam ni dia tak specified. Sebab apa tak specified? Maksudnya A ni adalah satu kan, A and B satu and then ni 1 kosong. So maksudnya dia ada possible of jadi 1 10. So dia ada possible of 00, 01 tapi dia tak specify. So bila dia tak specify yang ni, so dia akan create unwanted latch. Okay, unlike ni lah, kalau yang ni dia specify all. Ini kalau 11, ini kalau 10, kalau 01, sorry, 01, kalau 00. So ini specify all. Dalam kes ni, different lah banding dengan kes yang condition ni. Condition ni yang ni tak di-specify. And then dia akan create unwanted latches. So not all possible input for A and B are specified. Okay. So solution. So you mentioned here, if a Verilog code is written using if statement with all possibilities being specified, a latch will be inferred. Latch ni is actually unwanted latch, latch yang kita tak nak. Okay. Now, what is latch? Latch ni macam ni lah. Latch macam ni. Di sini. Always. Apa signal? Contoh clock. Okay. Ini latch. Latch ada yang wanted, ada yang unwanted. Kalau dalam kes ni, unwanted lah. Always at clock A pun juga B. You update with A. So this is latch. Level sensitive. So unwanted latch is not required in design lah. So we need to have a complete if-else statement to avoid the unwanted latch. Bila you ada unwanted latch ni, you punya design akan jadi besar lah, bigger than the required one. So to see this, normally we do synthesize. You synthesize using quarters tu, you tengok lah the effect. Okay, solution dia, to avoid unnecessary logic usage, we use else statement. Okay, that will specify all the possible. Okay ya. Logesh Warren, dia nak cakap sesuatu kah? Any question? No, okay. So write a Verilog code. So this is example. Okay, you can do this exercise. So I give you, maybe you do next week lah, during the free time tu, you buat ni. Write a Verilog code using conditional if-else statement without latch inference that represent the function of this table. Okay, so you boleh represent using if-else. Okay, so this one.
Sir, without latch interference.
Yeah.
Without apa tadi?
Sorry?
Tadi saya cakap without latch interference. Macam mana tu?
Ni. Kat atas ni. Baca balik atas ni. Yang ni.
Okay, baik.
So maksudnya, you kena specify if else. You tak boleh if without else. Contoh macam ni, nampak lah? If and then else if, you tak ada else kat sini. So ni not all possible input specified. So dia akan create unwanted latch. Unwanted circuit lah, unnecessary logic. Okay, so we mesti ada if else. Sekejap lagi kita tengok contoh dia. Okay. Saya ada kat bawah pun. Satu lagi case statement. Case statement also important. We need to have default kat sini. To avoid unwanted latches. Tapi dalam case yang macam ni, so we have 4 input here, okay, and then selector pun cover up to 2 to the power of 2 tu lah. Ni 4 possible input. So ini pun dia dah cover 4 possible input lah. Okay, selector tu dah cover 00 sampai 11 betul lah. So 00 sampai 11. So in this case, default is optional. Maksudnya tak perlu bubuh pun tak apa, tak perlu letak pun tak apa. Right, it's okay, but it's a good practice to have the default written just before the end case lah. You letak pun tak apa, because this is a good practice. Okay, ini untuk implement this 4-to-1 multiplexer. Okay, So another example untuk case statement like this one. So ini perlu letak default ataupun tak? Perlu letak tak kat sini default?
Tak ada.
Perlu.
Perlu.
Require.
Do we need to have default after this before and case for this example?
Before and case.
Do we need to put default or no?
Can if one.
Can if one. So once case can if one, or is that compulsory?
It's not compulsory
It's not compulsory. Why?
because we can still it still won't touch.
Yeah, look at this one. We have selector kan. Kita nampak ini selector. Selector is how many bit? 2 to the power of 2 bit kan. So we have 4 possible combination of the selector, which is 00, 01, 10, and 11. So far in our code, we cover until this, right? Nampak tak? Okay, nampak tak? So we have the other two is not covered here. Do we need to put default or not? Perlu tak kita letak default? No answer.
Tak pasti rasa.
Tak pasti. Okay. So kalau kita recall balik lecture yang atas tu, slide yang atas tu, kalau tak pasti tu maksud tak faham tu. So let's do revision. Yeah, wait ah. So it's mentioned here. Bukan yang ni. We go find the easiest one lah. Easy to understand. In this case satu.
Sir, tadi cakap a good habit to use. So kalau tak guna pun boleh juga kan?
Okay. Case yang kamu tanya tu adalah this one. Okay. This one, yeah, you are correct for this one. Okay, you put default ataupun tak doesn't matters because we already cover all the possible input case ni, select ni. Kalau tengok select ni 2 to the power of 2 dapat 4 kan, maksudnya 2 bit here. So input tu 00, 01, 10, and 11. Nampak tak dia cover semua ni sebenarnya dalam coding. Nampak tak?
Okay.
Okay.
So, kalau dia nak specify yang lain, masa yang perlulah letak default.
Ya, betul. Tu nampak dah faham. Good. Okay. Bila contoh macam ni, it's optional. Pilihan sama ada nak letak default ni ataupun tak. Tetapi it's always a good habit lah to have the default statement here walaupun dia cover semua input. So ini case yang macam ni. Okay, case. Kalau case macam ni, kalau you tak letak default pun dia akan okay, dia tak akan create unwanted latches. Tapi kalau case macam ni, the same multiplexer tapi you hanya gunakan 2 sahaja input, masukkan ada 2 saja. Tetapi selector you ada 2 bit. So 2 bit tu adalah ada 4 possible condition. So in your coding, you hanya cover 2 sajalah sebab design you nak 2 input saja, betul tak? Tetapi dalam case ni, the remaining here, we still have possibilities of the input tapi tak di cover. So kat sini you kena letak apa?
Letak default.
Yes, you kena letak default. Okay lah. Hope everyone also clear lah. Then the answer is here lah. You letak default. Okay, to avoid unwanted latches. Alright.
Last question, the default equals to dx, apa beza dengan default y equals to 0? Apa beza dia?
Sorry, default equal to?
ni y equals to 0, yang atas tu y equals to dx tak silap.
Oh ni, okay. Okay, this is actually x can be 0, can be 1. Ingat tak? Data x ni, unknown value ni can be 0, can be 1. So maksudnya, you punya y ni, it can be any. Ataupun you also can put y equal to a, for example. Also can, no problem. Okay, y equal to a, equal to b, equal to c, or equal to d. So that's actually means by default. Okay, kalau yang ni, y equal to 0, maksudnya you set y equal to 0 lah. Can be, you can put also y equal to a, no problem. So maksud, this is just to avoid unwanted latches.
So kalau y equals to 0, nanti tak akan pergi 1. Macam tu ke?
Bila y equal to 0, you akan, you punya circuit tu tak akan create latches, circuit lain. Maksudnya, selain daripada 0, 0, maksudnya macam ni. Selain daripada 0, 0 and 0, 1, which is 1, 0 and 1, 1 lah. Kalau selector equal to ini. Okay, kalau selector you equal to ni, either 1, 0 ataupun 1, 1. So, dia akan pergi kepada y equal to 0. Maksudnya output y tu dapat 0.
Okay, faham.
Okay,
Dia filter.
Ya, dia tak akan pilih A ataupun B. That's actually the meaning of default here lah. So actually the point here is really not to create unwanted latches. So dia tak mau unwanted latches because dia akan infer logic dalam kita punya design, unwanted logic. Okay. Right. This is additional information you may read on your own. Okay. So here is actually what we call as case versus conditional if else. So case statement represent multiplexing. So when to use case, when to use if else. So that's actually the point of this slide lah. Okay. So normally case statement ni untuk multiplexing. Macam you nak design multiplexer, for example, if you are designing a multiplexer, normally we use case statement. Okay. So it create balance logic. Okay. And then in terms of logic utilization, case statement utilize more logic lah compared to the if statement, if else statement. Okay, and if else statement normally we use to create priority encoded logic, like you have if reset, for example, you set the priority. If reset, okay, and then do for example C out equal to 0. We want to prioritize this first. Make C equal to 0 first. And then else, baru you buat, then you do the other process. So that's what we call as priority. Okay. For a case, it has no priority. Okay. For example, like this one tadi. Okay. So case select equal to, for example, 1, 1. 1, 1 which is 3. So it will jump to 3 without any priority between 0 first, 2, 1, 2, and so on. So that's why we call as no priority. So depending on your design lah. So normally it's used for design multiplexer lah, if case statement. Alright. So this is actually an example of multiplexer using case and using if else. You can also use if else, no problem. Tapi in terms of execution, it will check one after another lah. In this case, you can check it dulu. Selector tu sama dengan 0 ataupun tak. And then move to the next one. Selector equal to 1 or not. If not true, and then go to the next one until they find the true. Baru dia akan give the output. Compared to this one, if selector to equal to 3, for example, as I mentioned to you, they go straight to this one. Both are correct. Okay, but in terms of the logic balance and also the time, different. Okay, okay. So it depends on the question. If I ask you in exam, if I ask you to do using case statement, and then this is actually example. So if using if else, this is the example. You can try these two pieces of code. Try in quarters. Okay. and then try to see the equivalent RTL. Check the equivalent RTL. And then you can also try to remove this default. Try to remove this default and see what happened. And try to remove this else. Okay, you remove and then see what happens. Okay, so you have two exercises lah. Exercises to do lah during your free time. This is exercise number 2. Number 1 tadi tu, I think somewhere kat. Ni exercise number 1. Boleh buat lah. Okay. Any question? Ada soalan tak? Before we go to the next one ataupun I think 350 already. Okay. I think this is actually the same, almost the same. The same thing lah, we repeat assign statement, initial, always, recap, and then assign statement, normally, as I mentioned to you all, has to be a wire data type, yang variable ni, mesti wire data type. Okay, and then here is actually the expression. For example, we are designing a multiplexer, for example, 2-to-1 multiplexer. This is a selector. Okay, this is A and B. Okay, and this is Y, for example. So in terms of coding, find Y equal to S. Okay, and then we letak cell lah, cantik sikit lah. In selector and cell. Okay, Y equal to F. So you check adakah cell equal to 1. If equal to 1, so let's say we define this equal to 1. This is 0, for example. So if cell equal to 1, what happened? Y equal to A. And if not, Y equal to B. So that's actually example of assign statement. So Y ni mesti wire data type, must be wire. So this is for continuous signal assignment. Ini just macam revision. So, okay, single pass behavior we did in our what we call test bench. Okay, it's actually one shot activity, no repetition. We not repeat. Okay, you can see the example in our lab. So, initial only execute once. Okay, not repeat the stimulus. Okay, or the input. So you start always, and then it will repeat. Example here lah. Okay. Right. So here, initial A equal to 0. So means that initially we set the initial value of input A equal to 0, and then we set reset equal to 0, and then after 10 time unit, and you can see after 10 time unit, reset equal to 1. Okay, for the duration of 5 time unit. That's why here 1 for 5 time unit, and then the remaining reset equal to 0. Right? So this one we skip first. Okay, we focus on the initial. So this pattern will not repeat lah. Will not repeat. Only once only, because we use initial. But if we substitute this with always. Okay, so kita letak ni always, and then this pattern will keep repeating. Dia akan dapat balik pattern tu. So that's how we create clock actually. So you start sini clock, CLK, and then CLK equal to 0, and then you akan get the clock. Alright, so this is the explanation. And then cyclic behavior, we also learn about this one. And read on your own. Okay, so age sensitive and also level sensitive, as I mentioned to you. So level sensitive to represent combinational circuit, age sensitive to represent a sequential circuit. Okay, here is actually an example of a full adder. Okay, this is actually a combinational circuit lah, because this is a level sensitive. And then this is example of the single pass versus cyclic. So single pass and cyclic. So run when simulation start and terminate when the control reach the end. Maksudnya sampai di end sini habis. Yeah, this one different. Always ni, it run when the simulation start, yes, same as this one, but it will restart. Maksudnya it will repeat the statement here. Will not stop until you end the simulation by pressing the stop button. Okay, otherwise it will keep repeating or keep restarting. Okay, not like the initial only one. Always it will keep repeating or restart. So always good for modeling specifying hardware used in synthesis, as I mentioned, but for initial is not used in our design, not used in synthesis. It's good for test bench. All right, so if I ask you to differentiate between these two, initial and also a single pass behavior and also cyclic behavior, you should be able to differentiate and also give the explanation. You can use this slide as an example, try to understand and elaborate on your own. If I ask you to come up with an example, you come up with a very long example using these two different model, then you can also predict the equivalent waveform. For example, waveform for single pass and also waveform for cyclic. So that's actually the expectation. Understand this. Any question? So this is actually how you represent a clock lah. This is generate one. Okay, we use parameter. So how long is actually the clock period? How much is T? Apa boleh jawab? T equal to berapa T?
60.
T, clock period. This is actually we generate the clock signal ni. Okay. Clock signal. Okay. How long is the T ni? Berapa T ni?
100. 100.
Kau tak dengar?
100.
Yeah, okay, good, betul. Yeah, 100. Why? Because we define at the top, ni 50, nampak tak? Ini 50. So on every 50, dia akan invert the clock. Nampak tak dia invert? So ini 50. And the other one also 50. So total 100. Okay, good. Alright. Sebab dia boleh jawab, saya stop lah kelas. Okay, we cover part 2, I think, later lah. Okay, later. Right? Di week 7. Okay, I think that's all. We continue on week 7, this one. If you have any question, you can ask me. I'll stop the recording.